Hello, everybody. Thank you for joining us today for the Envirothon webinar. My name is David Haas. I'm the unit forester for CAL FIRE San Bernardino unit, and I'm also a member of the Envirothon Resource Advisory Panel and the Forestry team. Today, we'll be presenting a webinar on wood products and bioenergy. And that's pretty much my role in all this. I will turn it over to our presenters. We'll be monitoring the chat for questions. If you have anything super relevant and pertinent, you can raise your hand and we'll do our best to get your question in there. Or again, we'll monitor the chat. So without further ado, Chief Butcher, take it away.
Thank you, David. I'm going to
Jason, are your slides like fast forwarding?
Jason, I don't believe you're sharing your audio or sharing for video.
say that again.
I don't believe you're sharing your audio or sharing for video when you did share your screen settings.
Interesting.
You have to check the little boxes at the bottom when you click share screen.
Well, that sucks. First one. All right. Take two. Okay, sorry for the false start. Hope you enjoyed that short action video and it caught your attention. I think the video really highlights the diversity of activities and jobs our employees perform. I think it's important to share with you now, as many of you are thinking about your futures after high school, or even futures after college. Good afternoon. I'm Jason Butcher, forester with CAL FIRE's Wood Products and Bioenergy team. Today, I'll be talking about how CAL FIRE and other state agencies are promoting advancement of green energy and the increased utilization of forest biomass. Our special guest speakers are Sutton Goldner, Head of Business Development, and Farrah Powell, Senior Program Manager for Arbor Energy. They have a unique first-person perspective as pioneers in both the bioenergy economies and the technologies which will advance California towards its carbon neutrality goals. So here's a quick overview of what we'll be covering in today's presentation. First, I'll summarize California's renewable energy goals, cover the traditional forest management processes CAL FIRE regulates, discuss our fire risk reduction activities, and lastly, I'll discuss how CAL FIRE influences or participates in California's forest health, wood products, and bioenergy development through our various grant programs. Then our energy will discuss the sort of current challenges with utilizing biomass, new approaches to biomass utilization, their types of approaches that are out there, Arbor's approach. And lastly, some roles that are needed for sustainable forest management. We anticipate about a 60-minute slide presentation followed by 15 minutes of questions. So California is recognized worldwide for its clean energy goals, its aggressive policy to combat climate change, and its promotion of sustainable energy by transitioning its electricity system to rely increasingly on clean or renewable energy sources such as solar, wind, geothermal, hydroelectric, and biomass, basically non-fossil fuel sources of energy. So California established a 100% zero carbon goal by 2045. So simply put, net zero means cutting carbon emissions to such a small amount of residual emissions that they can be absorbed and durably stored either by nature or by other carbon dioxide removal measures, thusly leaving zero in the atmosphere. To achieve these goals, many of California's government agencies play a role in development and adoption of renewable energy. For instance, the California Energy Commission jointly administers the state's renewables portfolio standard with the California Public Utilities Commission. This will ensure the state's investor-owned utilities disclose their electricity supply portfolio to consumers. They also provide funding to programs to support renewable energy development and then track the state's progress towards its renewable goals. The Renewable Portfolio Standard required electric utilities to procure 33% of their retail sales from renewable sources by 2020, 60% by 2030, and achieve 100% clean energy by 2045. Legislature recently signed a new bill, the Clean Energy Jobs and Affordability Act of 2022, which defined new interim state goals of 90% renewable sources by 2035 and 95% by 2040. So CAL FIRE plays a role in achieving these goals too. Surprisingly, a tree can have more products derived from its harvest beyond lumber, plywood, and paper. As transitions occur from fossil fuel dependency to renewable fuel sources, more investment in biomass utilization is necessary. Both federal and state investments are required to achieve this transition. Beyond the renewable energy goals, California also has statewide forest treatment goals. We call it the million-acre goal, to address unhealthy forests that are in jeopardy from changing environmental conditions. These treatments require a all hands, all lands approach with partnerships bridging private, tribal, state, and federal ownerships to accomplish the mission. CAL FIRE performs and supports many activities which create resilient landscapes and healthy forests, providing a future capable of weathering erratic climate conditions that promote catastrophic wildfires. Our forests are one of the largest natural airborne carbon sequestering mechanisms we have. This carbon storage is critical to combating increases in atmospheric carbon and thus helping us reach zero carbon solutions. Much of the underlying issues with forest health revolves around the carrying capacity or trees per acre in the forest. Through forest management activities like timber harvest and fire risk reduction treatments, forest health and resiliency to stressors like drought, insect, and disease can be mitigated. So this dashboard was copied from the California Energy Commission's website, and it shows California's status relative to those renewable portfolio standards targets. If you notice the biomass in red, the red bar, that's an area we can improve. We need to improve. It's an opportunity to provide more baseline power. Now, baseline power is available when the sun isn't shining and the wind isn't blowing. We currently have a heavy reliance on burning natural gas and other non-renewable fuels to produce our baseline energy needs. California's natural gas output has steadily declined since 1985, and the state now accounts for less than 1% of the nation's total natural gas reserves and production. California's natural gas production is less than 1/10 of its total consumption. By increasing the capacity of biomass energy sources, California would be poised to accept more material from the 1,000,000 acres per year anticipated to be treated. So, if you add renewables to large hydro and nuclear sources, neither of which produce greenhouse gas emissions, energy production in California stands at 59% clean energy as of 2021. So we met our goal. The rest of that one goal, the rest of our energy was produced using non-renewable sources destined to run out, sources responsible for greenhouse gas emissions. Shifting focus on improving the renewables percentage, we land on biomass. California has a lot of biomass. Biomass comes in many forms. By definition, it's a renewable organic material that comes from plants and animals. Biomass contains stored chemical energy from the sun that is produced by plants through photosynthesis. Biomass can be burned directly for heat or converted to liquid or gaseous fuels through various processes, some of which will be discussed later by our guest speakers from Arbor Energy. However, I tend to think of biomass as every part of a tree that cannot be a board. But as you heard, biomass has a broader definition, and that often gets critics excited if they think you're advocating using a tree for biofuel or bioenergy instead of using it for housing. So beware of the difference between definitions and interpretations. So CAL FIRE's mission emphasizes the management and protection of California's natural resources, a goal that is accomplished through ongoing assessments, studies, and an extensive CAL FIRE resource management program. CAL FIRE oversees enforcement of the forest practice regulations, which guide timber harvesting on private and state lands. Periodic reviews and inspections ensure the protection of watersheds and wildlife, as well as continuous renewal of timber resources. Department foresters and fire personnel work closely to encourage and implement fire risk reduction projects to reduce the threat of uncontrolled wildfires. CAL FIRE foresters often promote conservation and the importance of our trees and forests to Californians of all ages, much like we're doing here today. So traditional forest management involves a very regulated process to comply with the forest practice rules and the Zeeberg-Nedley Forest Practice Act of 1973. Operations are also guided by the California Environmental Quality Act of 1970. Each of these acts establish statewide regulations governing environmental review of discretionary projects and a process for mitigating or avoiding potential environmental impacts. Harvesting trees for commercial purposes requires a timber harvest plan, THP, which is produced by a licensed registered professional forester, an RPF, and approved by CAL FIRE after having received input from multiple state agencies like the Department of Fish and Wildlife, Water Quality Control Boards, California Geological Survey, and federal agencies like the U.S. Fish and Wildlife Service. So if you want to become a licensed registered professional forester, it typically requires a BS in forestry, a Bachelor of Science in Forestry, or a closely related field, and 3 years of practice under the direction of a licensed forester before you can sit for the RPF exam. This is an all-day exam which tests your resource management knowledge and requires an 80% to pass. So going back to timber harvest plans, after harvest plan approval and after all environmental clearancing is achieved, licensed timber operators, LTOs, fall the trees, process them into logs, and transport them to a processing facility. The facility may be a lumber mill, a plywood mill, a shavings mill, a chipping yard, an export yard, pulp mill. There are many other options. We'll focus on the higher and better use of the log. A lumber mill may produce many products using durable goods, thereby storing carbon. So think about your home. According to Google search, approximately 6.3 board feet of lumber is used per square foot of home. With the average home in California being over 1,800 square feet, that equates to over 11,000 board feet or 50 to 100 trees per house, depending on the tree diameter and height. Although it varies slightly by species, wood is roughly 50% carbon by dry weight. So a home represents a lot of stored carbon. Turning a tree into lumber creates many waste products: limbs, tops, bark, chip, sawdust. Each of these byproducts, called residues and residuals, have market potential. Most byproducts are low value or no value when compared to the lumber, and some waste require disposal at a cost, having negative value. So there are many ways timber is processed into logs. Hand falling was prominent before mechanized processors increased the speed and safety of operations. This is a feller buncher with a processing head that cuts standing trees, strokes them to remove the limbs, and then cuts them to length based on desired specs. So after the feller buncher with his processing head creates many log decks on the forest, the forwarder retrieves the logs and moves them to a landing, where a loader puts them onto a truck for hauling to a facility. Now, this is just one example of how trees are processed in feedstock for a facility or a mill. Another priority for CAL FIRE is fire risk reduction. Through community engagement and collaboration with local fire departments, other government agencies, and community fire safe organizations, CAL FIRE, along with these partners, develop and implement fire prevention and mitigation features tailored to the specific risks and vulnerabilities. These pre-fire activities and treatments enhance overall fire resilience and community preparedness. Clearing vegetation in wildfire-prone areas and creating defensible space around structures can help reduce the spread of fires and the loss of property. This involves removing dead plants, trees, ladder fuels, and other flammable material around structures or along strategic grid lines and roadways. This manipulation of material in fuel breaks, in which all the material is removed, or shaded fuel breaks where canopy remains and surface fuels are adjusted, separates the continuity of fuels, providing barriers which can help slow or stop the spread of wildfire, thereby protecting lives and property. CAL FIRE performs a variety of fire risk reduction techniques which aim to minimize the likelihood and impacts of fire. These techniques can be applied in residential, wildland, urban interfaces, and other natural settings. There are dozens of seasonal and dedicated fuels crews across the state, as well as inmate hand crews performing these valuable treatments. Treatments include prescribed fire, mechanical mastication, manual and mechanical thinning, piling, pile burning, lop and scatter, chipping. Treatment activities are recorded in a statewide GIS database and reported annually to legislature, providing a compliance report toward our 1 million acre treatment goals. All of these treatments create biomass with little or no value, which may be utilized as feedstock to bioenergy or biofuel facilities rather than to be left on the forest floor to decompose or burnt in piles. Risk reduction also occurs through education and outreach through our defensible space inspection program. The public is provided fire safety education and specific treatment recommendations that are made to homeowners or occupants in order to raise their awareness about their legal requirements or existing fire hazards, their recommended evacuation pre-planning, and other preventative measures that they can take. By integrating these techniques into fire safety planning and management practices, individuals, organizations, and communities work together to reduce the risk of fires and mitigate the impact on their lives, property, and environment.
In July July and August 2022, the Caldwell fire burned over 81,000 acres in Modoc and Shasta counties. In 2022, Dell Logging applied for grant funding for a new wood chipper operation. The project creates 50 new jobs in low-income communities and supports fuel reduction treatments in northeastern California.
We're out here in Tianesta, California today on National Forest land. The material that's chipped here is being shipped to Bernie, California, to Bernie Forest Power. That's a bioenergy facility.
We applied mainly because we were wanting to try and figure out how to get another chipper going so we could double up our capacity. There was such a demand for clearing and cleanup, and so the reason that we were trying to run another side was to keep up with that demand.
The annual production, estimated annual production on this machine will process about 60,000 tons, which generally would be about 4,000 acres of treatments a year. Chipping operation like this, in this case, it's post-fire fuel reduction, and it's going to set the stage for reforestation here. Also removing fuel, these piles, the material that's being chipped and taken to a bioenergy facility, in this case, if they weren't, they would be burned in place and not utilized. But having a chipping operation, the chippers and the trucks involved hauling this material to a bioenergy power facility turns this burned forest material into electricity. Our grants support to expand wood products infrastructure. So that might be a facility that processes wood, or in the case of where we're at today, a contractor looking to expand their capacity to get work done.
So great example of post-fire biomass utilization, also future fire mitigation, business expansion, job creation, utilizing a renewable resource. So this diagram provides a nice flow for various timberland material created through traditional harvesting or fuel reduction activities, and it introduces the utilization of material diverted from landfills. Biomass is an organic renewable energy source that maybe include materials from agricultural settings, could be forest residues, energy crops specifically, and algae. Scientists and engineers are finding new and more efficient ways to convert biomass into bioenergy or biofuels that can one day take the place of conventional fuels like gasoline, diesel, and jet fuel. Traditional forest management, hazardous fire reduction, and biomass or bioenergy facilities all require funding for implementation. Some of those opportunities come from grants sponsored by CAL FIRE and other state agencies. Some from venture capitalists looking to get in early on a biofuel or bioenergy investment. Even insurance companies are finding returns after investments in fuel reduction work, which saves them expensive fire loss payouts. Some investment firms are managing pension funds or other investment vehicles, investing in timber as a stable growth opportunity. However, the risk of wildfire can wipe out all their capital gains. So all these investments help manage the biomass in our forests. So CAL FIRE has quite a few grant programs that help support biomass utilization and creation. Our wildfire prevention grants fund, they support various types of wildland fuel treatments for the purposes of reducing fire hazard or severity. We have a forest legacy program, which protects environmentally important forests through conservation easements. Our wildfire resilience block grant program gives other entities large chunks of money and has them distribute and track the forest improvement projects. Our forest health grant program funds landscape level projects, utilizing fuel reduction, prescribed fire, pest management, and biomass utilization. The workforce and business development, the goal of that is to strengthen forest sector workforces and expand businesses in California, while also promoting healthy and resilient forests. We have a new program specific to our tribal wildfire resilience. Those grants go specifically to Native American groups so they can manage their ancestral lands. We have a rural fire capacity program, which provides funding for volunteer fire departments. The California Forest Improvement Program is a cost share program, which encourages private and public investment in forest lands to ensure that there's an adequate, high quality timber supply for the future. We have an urban program that adds trees into the cityscapes and community forests to reduce energy demand through shading or increase carbon sequestration. They can also contribute certain amounts of bioenergy or biomass generation. And we have some forest health research to get some answer any pertinent questions or find new innovative ways of dealing with some of our biomass or forest health issues. So the different grant programs focus on different activities. They can take different geographic locations. They can overlap. In this cartoon at the bottom where it says business and workforce, you can see the gear icon overlaps, signifying that these projects can take place in urban, rural, and wildland location. The business and workforce grants can be anywhere in California as long as they relate to infrastructure, wood utilization, forestry, and forest sector workforce training. So I want to talk about that program. That's the program that I work for, the Wood Products and Bioenergy. Our team awards funding for competitive businesses and workforce development projects to support healthy, resilient forests and people and ecosystems that depend on them. We have 4 primary areas of interest that include existing and emerging technologies. So we talked about the business development. That includes in-wood operations, transportation, solid wood, and biomass processing. We have bioenergy investment, which includes using biomaterial for power generation or biofuels for domestic and export. And then workforce development, applying at all levels, in-woods jobs, could be transportation, jobs, manufacturing, even prescribed fire and forestry. And then we have a small research and development program that's ancillary to forest-related businesses and workforce development. The Workforce and Business Development Grant Program has been operating now for 3 years. We've had 5 rounds of grant awards, currently sitting with 90 active grants, totaling $103 million, working to develop businesses and grow workforces. Our contribution to the Million Acre Strategy is to support the growth of businesses that will remove forest fuels and make use of the biomass generated. We work closely with other California agencies to further the climate goals. One of our business development grantees is Arbor Energy. They are working on a first of its kind bioenergy facility in Placer County, which will create valuable jobs and provide a destination for low value biomass. So with that, Sutton from Arbor will discuss mainstream biomass utilization option and Arbor's current project.
All right, Farah, you want to share the slides? Thank you, everyone. I'm Sutton Goldner, Head of Business Development with Arbor Energy. Farah, you want to introduce yourself real quick?
Hi, Farah Powell. I'm the Senior Program Manager at Arbor.
All right, next slide for us. You can go ahead too, because we're just going to start with the introduction. But as Jason mentioned, a lot of these forestry management activities, you can go to the next slide. These forestry management activities create a lot of what are referred to as low merchantable value biomass, also called residues, sometimes actually just referred to as biomass as a whole. And a challenge with a lot of these is that these are created as a byproduct of forestry management work, timber sales, line clearing. But right now, there's not an economic use case for a lot of this biomass. It can take a lot of different forms as well, as shown on the left. It can be anything from kind of small piles of sticks to massive piles of logs and everything in between. Piles can have huge amounts of ash, huge amounts of pine needles or bark that can also make it incredibly hard to process. Next slide. And if we look at the use cases for it today in the current California economy, there are kind of 2 main outlets for some of this biomass. Some of it can be, the high value stuff can be converted into commiserately high value products such as cross-laminated timber and wood chips, which can be used directly with minimal processing. And then the lower value products are usually used in energy. where they're typically combusted to generate electrical power. Shown in this photo is Jamestown Energy, a facility in Tuolumne County. And then below that is a biomass heater boiler system in the town of Quincy at Quincy Junior Senior High School. There's also utilizing waste biomass. Next slide. The challenges to using this waste biomass, however, are numerous, and is a reason that a lot of it is not going utilized today. One of the biggest challenges is just the cost of transporting and processing the material. Not only does this include the cost of course, getting it from the woods to its desired location, but even getting it from parts of the woods to the mainline roads. A lot of these roads are, especially into the woods, are older and not easily navigable by a lot of trucks, further increasing costs borne by delivery. Biomass itself is not very dense in power, so utilizing it in a traditional power setup can be rather inefficient, requiring lots and lots of fuel, which in turn has higher processing costs and transportation. Some of the specialty products mentioned on the previous page, such as wood chips and laminate timber, while incredibly good use cases, are not in as high demand as needed, or are competing with other products in similar categories. And finally, a lot of the processes that can convert this waste biomass into other utilizable things, again, even if it's laminate timber, do have emissions profiles that can make the deployment of these projects challenging, especially as we are looking towards a cleaner future. Next slide. So to address these challenges, we have to kind of put some creative thinking hats on. If you're going to have a really large cost associated with transporting your feedstock, you need to be creating a valuable product with what you're doing. If it has poor feedstock power density, you need this unique business case that doesn't fully rely on just the power revenues. The low demand for specialty products, while a challenge now, can force us to think about where could this be used in a higher demand setting. And finally, the local air quality concerns can be addressed by pollutant capture as central to your process as you're designing your system. Next slide. And so why does all this matter? As you probably know, California is in the middle of an increasingly dangerous and damaging set of wildfire seasons, with damage increasing year over year. And this is only from data that goes up till 2021. And if we can properly address these residues, the entire goal is that this will allow us to manage more forestry land, which is needed to address this wildfire crisis. By managing more land, you also create more residues. So there's a potential for this to become an incredibly self-sustaining process if we can really nab that one highlighted part appropriately, and that is the conversion of these residues into high-value products. Next slide. And I'll hand it over to Farah to talk at a high level about what Bikers is.
All right, so yeah, Bikers, or biomass with carbon removal and storage, is referred to as this kind of hybrid approach to carbon dioxide removal that combines photosynthesis with technology. So kind of breaking this down, plants generate a lot of organic matter or biomass, which contains stored energy or carbon that's captured during photosynthesis. When plants die and decompose, they release that stored carbon back into the atmosphere. But this process, known as Bikers, actually interrupts this cycle, preventing the release of stored carbon back into the atmosphere. So we can take this organic waste stream to a carbon conversion and capture facility where it's converted into electricity, which could be sent to the grid, meanwhile capturing all emissions from the conversion process and permanently storing captured CO2 underground. So Bikers facility outputs two products that can be monetized: clean electricity and high purity CO2, or carbon dioxide. We can sell the CO2 we capture as carbon credits on the voluntary carbon market for people or companies that care about sustainability. For any credits we sell, we need to show that they are additional, measurable, and durable. For additionality, basically what we're showing is that the carbon removed by a project or activity is beyond what would have occurred if the project did not exist. The next piece that we need to show is that the carbon removal that we're claiming and the process to remove it is measurable. If we compare this to another form of carbon removal, like forestation, which involves growing trees, it's a lot harder to measure. You can't just go out and easily measure all the carbon locked up in a forest. This has to be modeled as opposed to directly measured, which can add a lot of uncertainty and variability. And the last criteria is durability or permanence. We don't want to remove CO2 from the atmosphere only to end up being re-released in 100 years. So going back to the previous example, forestation as a carbon removal approach lacks permanence because it's reversible. Trees die naturally, and environmental disasters like floods or fires or land use change can all result in the release of CO2, which would negate any permanence. There are three kind of guiding principles of bikers. The first is do no harm. If a project threatens food security, rural livelihoods, or biodiversity conservation, then it does not qualify as a biker's project and should not be pursued. The second is that social acceptability is key. So without support and demand from a wide range of stakeholders, bikers' processes will not and should not reach significant scale. And lastly, technology development should reflect social priorities. Basically, these technologies shouldn't be pursued for their own sake. They should actively contribute to achieving the economic and social goals of the communities that are most impacted by their installation and operation. So there are several different sources of biomass that constitute as waste. There's forestry waste, agricultural waste, municipal solid waste. All of these different waste streams have different counterfactual scenarios or scenarios of what would have happened in the absence of a project. In the case of forest residues that are generated from forestry management, in the absence of a project such as ours, these residues would be burned in piles or left to decay on the forest floor. And we need to model emissions from those counterfactual scenarios, which are very specific to a given project and to the type of waste you use. In relation to measurability, in order to accurately account for how much CO2 we're removing, we have to account for emissions from every step of our process or the whole life cycle. So let's say we get a bunch of forestry waste for our carbon removal facility, but this waste is coming all the way from Maine. So we have to truck all that material really far, which then generates a lot of CO2 from transportation. So then we have to account for that and subtract any positive emissions that occur for the entire project lifetime. You can see in this example here that all emissions from each process, which are the blue boxes there, like biomass harvesting, transport, conversion, injection, they all need to be accurately accounted for and reflected in final estimates of removal. Where is all of this CO2 going, and how do we ensure that it's permanent? We will be storing our CO2 thousands of feet below the Earth's surface into the same geological formations that have safely held oil and gas for millions of years. These CO2 storage reservoirs are called Class 6 wells, designated by the Environmental Protection Agency. The captured CO2, which will be in a liquid form, is injected into tiny holes or pores in the solid rock, which is similar to the way that water is captured in a sponge. These would-be emissions are trapped permanently in the pore space of these geologic formations, kept in place by repetitive sequences of overlying impermeable rock layers that essentially act as seals to prevent the carbon dioxide from being re-released. There are several different approaches to bikers, which you can see here. The most mature bikers technology, technologically mature, is biochar, which involves heating biomass to produce kind of a charcoal-like soil additive and can be seen in the top left image. Another approach is what's referred to as bio-oil. Through a similar heating process, a carbon-rich bio-oil is produced and injected into abandoned oil and gas wells where it sinks and solidifies in place. And an even more novel approach is called woody biomass burial, depicted in the bottom left image, where dead biomass is buried deep underground in a vault to prevent decomposition and release of stored CO2. While each of these have fairly low technology risk, there are a handful of inefficiencies in the processes that challenge their ability to scale at the rate that we need. And Sutton will speak more on that.
All right. And so what do we do at Arbor? And what is Arbor? So at Arbor, we are a team of former rocket scientists and energy aficionados looking to deploy a brand new technology for this biker's process. A lot of our team comes from the novel aerospace industry, including companies like SpaceX, Virgin Orbit, and GE. And then several of the rest of us come from more traditional energy backgrounds, such as large energy companies or alternative vehicle companies. And then the next slide. And our theory is at a high level that what we were doing is essentially strapping a rocket engine to the ground and feeding it trees, what we like to call a vegetarian rocket engine. The goal is that by deploying a lot of these technologies that are already frequently used in the aerospace industry, we can get significantly faster deployment, smaller deployment, and higher scale deployment across the entire state versus conventional processes. Next stage. And so what our process does is it takes in these waste streams from forestry management, and it actually optimizes for the waste streams that are some of the hardest to deal with, such as chips, bark, needles, and all of these kind of dirtier streams of waste. We go through a sizing step before going into torrefaction, then grinding, gasification, oxycombustion, and then a supercritical CO2 power. And we'll get into what each one of those means on the following slide. The byproducts, go back real quick, sorry. The byproducts that we create are a small stream of water, as well as biogenic ash, which means this ash is made of metals that were originally in the trees themselves. All biomass facilities, even the conventional ones today, handle these waste streams, and they're usually utilized in agricultural deployments as fertilizer or soil amendment. We also create electrical power, which of course can be used in all sorts of ways. And then finally, as Farah was mentioning earlier, we create purified carbon dioxide, which we will truck to one of these Class 6 well locations and store permanently. Next slide. So in terms of the technologies that are at play, our first step after size reduction is what's called torrefaction, which we like to compare to roasting coffee beans or making charcoal. It takes wood chips in and outputs a product known as biocoal, which is, again, very similar to charcoal. It is essentially wood that has been dried out intensely, and due to a low application of heat, has broken down a lot of the chemical bonds and tars and lignins that cause problems later on in the process. It also, returning to the coffee bean analogy, allows us to break apart the biomass into a fine dust. If you took a raw coffee bean and you hit it with a hammer, it's just going to squish, versus you take a roasted coffee bean and you hit it with a hammer, it's going to shatter into a ton of pieces. And that's exactly what we want, because we want to pulverize this into a fine dust. That fine dust goes into our gasifier. And a gasifier is kind of a fancy name for a really hot vessel that breaks down molecules into gases. Or not breaks down the molecules, breaks down solids into gases, I should say. This takes that pulverized biocoal in and outputs what's called a syngas, which is itself a fancy name for a mixture of gases. This gasification process also handles the ash stream mentioned earlier as those solid metals deposit out of the bottom of the gasifier. Now that our process is in the gaseous phase, we can move it around a lot easier and use it in much more standard processes. So we will then send that syngas, which contains a lot of carbon dioxide, carbon monoxide, and hydrogen, into our oxycombustion chamber. And this is kind of the heart of, again, that vegetarian rocket engine, where we're sending this mixture of gases into the combustor, mixing it with oxygen, and outputting a high pressure, high temperature CO2. While if this was unconstrained, that would look rather spectacular, it is, of course, all safely within the confines of this industrial process, and that high pressure CO2 then goes and is used in our power generation loop, extracting usable energy from that high pressure CO2, and then separating that CO2 for liquefaction and storage, again, in those Class 6 wells. All of this, though, or not all this, but the oxy-gasification, oxy-combustion, and supercritical CO2 loops are the heart of Arbor's technology. And through the development of them is how we kind of justify our value as a company. And all of this is incredibly intense and novel engineering that goes through a lot of the traditional processes that you might have seen if you've taken an engineering course. So all of this begins, of course, with design, starting not with some sketches on a blackboard or whiteboard, and then going into computer-aided graphic design and modeling. Next slide. So this, what we're showing here is the oxy combustor itself. This piece of equipment is about the size of a large water bottle and is capable of throughputting about 10 megawatts of thermal power. This is some rapid prototyping, and so part of the design of our technology allows for the rapid or for the utilization of 3D printing technology. Of course, here it's being printed in plastic, which is not for the final design, as you might imagine, but is for rather us to get a sense of the scale, size, and design characteristics of what we have. We play around with that prototype before finalizing the design and then moving into manufacturing. You want to go to the next slide? And so here is the test bed where we're actually 3D printing these combustors out of metal using what's called a sintering printer. So what this printer does is it lays down a level of powder that then lasers go through and melt individual grains of this powder to the layer below them, additively, slowly but surely constructing what you're wanting to 3D print out of metal, as shown on the right. And so that's about 5 of those combustors on the exact same printing plate. Next slide. This is a part of the value of 3D printing is that it lets us get really exotic with the design inherent in our processes. So you can see some of the features in these combustors that allow for the flow and mixing of these gases would be impossible to machine through conventional manufacturing practices. By freeing ourselves from that, we can rapidly iterate, prototype, redesign, test, all keeping this in-house and at a much faster speed. Next slide. And finally, of course, the interesting part is the testing. So we currently have this test site in the Mojave Desert where we have been testing these combustors. Right now, the back end of them is not hooked up to the power generating side. So essentially it is free and open to air. And we've started to come up with some test footage of this process. If you want to go to the next slide and play the video, turn the volume down too, because it is loud. And so here is now the active combustion testing at the Mojave. As the combustion becomes cleaner and cleaner, the flame plume actually becomes harder and harder to see as we near what's called perfect oxy-combustion. In this last video here, the combustion gets so pure, which is exactly where we want it, that you actually can't see the physical flame. And here's a side-by-side of the thermal camera and the real camera next to each other, showing the exact same event. You can just play the rest of the video. So you can see the probe there moving because of the intense high pressure stream. But of course, on the visible spectrum, there's absolutely nothing to see, as this is pure CO2 and steam ejecting out the back, both of which are invisible gases. All right. Next slide. I guess I'm going to replay. And so why are we here talking about this? Next slide. And so if you had asked me in high school, it's a photo of me in the bottom corner there, back I think I was a junior in college, or a junior in high school then. What kind of roles are needed in forestry management? I think I would have had a really limited view of the world because this was not an industry that I had a ton of experience with. As part of working with Arbor, that view has rapidly started to broaden, getting to know the groups of teams at CAL FIRE, the Forest Service, and with our project partners. Next slide. But what we're also here to kind of lean on is that part of forestry management can also be the development of these high impact technologies. After all, we fit into the forestry ecosystem by being able to utilize the waste feedstocks that come from these operations. So you want to go to the next slide? So that includes groups like us at Arbor, right? Where we don't have some of the traditional backgrounds that you might associate with forestry management. We have mechanical engineers, process simulators, fabricators, data scientists, software engineers, all working on these complex technologies, trying to turn them into a reality for the better of the forestry system. Next slide. And so we can add them to the list as well. And now that list starts to get longer. Next slide. And of course, the development of this technology is just one part of what makes these actually part of a functioning facility, right? Even if you had a perfected technology, someone has to operate it and make this part of something that can produce electricity and carbon credits. And so now we can broaden our view even further. Who else is involved in the operation of these biomass facilities? We have equipment technicians, welders, supervisors, fuel managers, installation engineers, scaffolders across the entire system of trades. Next slide. So we can add them to the list as well, and it continually gets longer and longer. Next slide. And these projects are also don't exist in isolation. They themselves are a response to the waste streams coming off of different parts of the forestry system. But it takes more than just these facilities, or these facilities don't come out of nowhere, and they interact with the rest of the entire economic ecosystem, including labor unions, groups like banks that need to finance these, groups that do the research on where to best site these facilities, or where to best site the Class 6 wells that the CO2 will go into, groups that regulate all of these activities to make sure that we're staying in the confines of the air permits that we're operating under, or people trying to balance the electrical loads that we're producing and managing utilities. Next slide. So as you can see, the types of roles that can have their hands tangentially and directly related into this forestry management ecosystem gets incredibly broad the more you think about it. Next step. And it's less so about the specific training or background or interests that you have, and more just about your underlying passion. Are you interested in getting involved in forestry? And if so, how can you do that with this set of skills that you have? As we're pulling from people with a huge diversity of backgrounds, from STEM to finance to government relations, technology, labor and trades, and community. And I'll let Farah now talk about a bit on the government and community side.
So Arbor is taking a very community-centric approach to our project development, meaning that the community is really at the core of our planning. So given all these different industries and groups and expertise coming together for the deployment of a project, as Sutton was mentioning, this means that we have a very diverse set of stakeholders that we engage with, spanning federal, state, and local government, community-based, non-governmental, or advocacy organizations, workforce development and labor groups, community colleges, and traditionally excluded or disadvantaged groups. And to the right here, you can see these are many of the stakeholders that we regularly engage with or are partnering with for our upcoming demonstration facility. For this industry, viability long-term is strongly tied to workforce development. And with this transition to a low carbon economy, demand for labor across these sectors is skyrocketing. Bioenergy is a very decentralized technology, so it can be deployed in a very localized way with an opportunity to make it accessible to everyone, but a lot has to go into the process to make it truly accessible. So, once we are operational, our project will create about 350 construction jobs in clean energy installation. And we're engaged with local building and construction trades councils, labor unions, and pre-apprenticeship programs to ensure that the employment opportunities and skills training explicitly utilize the local workforce, as well as historically underserved or low-income communities. And our actual facility will create about 30 jobs in power plant operations, maintenance, and administration, and about 20 to 25 off-site jobs across the biomass and carbon management supply chains. Again, given that there are a lot of different groups trying to achieve similar outcomes in terms of forestry management, renewable energy, and job creation, it's so important that we work collaboratively with local forest products businesses, stakeholders, and regulatory districts to ensure that we're all working in concert, leveraging each organization's strengths and resources. Workplace diversity, equity, inclusion, and accessibility, or DEIA, is also at the core of our planning, which is why we've identified a handful of local minority, women, and veteran-owned, as well as disadvantaged business enterprises that we'll use for contractual services. We'll also provide a lot of career track training, internship, and apprenticeship opportunities for career development. To do this, we look at what educational resources are in the area, and are there academic and workforce stakeholders who can be brought into the project? Can we collaborate with them to augment existing efforts to create new programs that address this whole range of clean energy, carbon removal, and forestry management? And the answer is yes, and we are actively pursuing these pathways. And finally, we have the public outreach and education piece, which can involve participating in job talks and career fairs, presenting at conferences, or any kind of career-connected learning opportunities. We want to expose people, especially at younger ages, to all these amazing opportunities that are out there and help students or individuals determine kind of the necessary skills and qualifications that they'll need to excel and advance in a career pathway such as this. Our community engagement process covers an entire spectrum of stages and activities designed to kind of go beyond simply informing a community of our plans. Our goal is to include communities and affected groups in the decision-making process, collaborate with, and empower them. There are different activities and approaches we use for various stages of the engagement process, which you can see here, in order to build trust, build community capacity, and promote social equity. Ultimately, the involvement of local communities in renewable energy projects is essential for their success. By providing local people with the opportunity to contribute to projects that will benefit them and the environment, renewable energy projects can be both successful and sustainable. Finally, and as mentioned earlier, we were recipients of CAL FIRE's Business and Workforce Development Grant Program, which speaks to the importance of federal and state agencies, not only for funding and getting these projects on the ground, but also in the relationships it brings. So we just want to thank CAL FIRE for including us, and it's been a pleasure working with and learning from them. And that concludes our presentation.
Well, thank you to all the presenters. That was very cool. A very novel approach to something that's plagued the timber industry for years. How do we create a value-added product out of something that had traditionally been regarded waste and have the additional environmental and social benefits? So that is very cool. I appreciate all the presenters. We did have a couple of questions come in. So do you have chat open? You want to just take them as they come? First with Jovita. Example, how energy, yeah, go ahead, Sutton.
Yeah, so there's actually quite a lot of interesting applications of how the energy can be used. Obviously, the most straightforward is plugging into the electric grid, which means that essentially any customer on the electric grid in California can use it. However, with bioenergy, you have a few interesting opportunities where the biomass itself is in, we're thinking about the Sierra Nevadas, not close to a lot of the industrial centers of the state. And there's a lot of kind of smaller isolated communities in these areas. And so there's actually a really powerful application of this project in what are called behind the meter or distributed energy resources, where we could use this power to provide energy and rural electrification to these smaller communities using the very residues that the economies of these communities runs on. For our first facility, we're actually planning to partner with a local water agency and provide their wastewater treatment or their freshwater treatment plant with behind the meter power for processing the region's water. I see also, what is the projected cost for the Arbor system and how many do you expect to be at each site? It's also a good question. So the first unit that we're building will be very expensive because it is a test article, and there's a lot of interesting conversations we can get into about how one finances that, part of which grants are a huge part of that picture. The long-term costs that we're looking to get to, though, is that one of these facilities is about double the price per megawatt of solar power. So while the power is more expensive, it's also carbon negative rather than being carbon neutral. And it also is, as Jason mentioned, baseload power, often also called dispatchable power, which is incredibly valuable because that actually even allows you to put more solar on the grid. Right now, what prevents you from putting more solar on the grid is that too much solar on a grid can make the grid unreliable. And so you need to back it up with some sort of power that can respond to solar's fluctuating production curves. But by being able to put these assets on, now you can put even more solar on so that you can respond to them with these assets. I think, Jason, that's a question for you. I'm not as familiar with the operation of a feller buncher.
Yeah. There's a lot of perspectives on that, but typically the feller buncher, it has a very distributed weight per square inch because of the rubber tires or the multiple tires. And it is also usually walking on its own slash as it falls a tree and it limbs it, then it walks on it. So some of the operations I've seen, no, there's not a significant amount of erosion, if any erosion. And then the other side of it is typically to meet the forest practice rules and requirements. Any of the trails that were utilized, if they were to scrape out or create a skid trail, it would have to be water barred to mitigate that erosion.
Good old good old fashioned classic forestry right there. So I have a couple questions for Arbor, and whether that's Sutton or Farah, I'll let you the first. So what is one of the big issues with biomass energy, right? Sawmills have been using some kind of biomass energy, since they've been able to do so, burning their slash and using that to power the sawmill. What do you see as what's the input to output ratio? How much material do you need to keep this thing running, presumably 24 hours a day, 7 days a week? And what's your feedstock needs?
So that'll depend, of course, on the size of the system. But for the 3 megawatt system that we're planning to build in Placer, that'll utilize around 45,000 bone dry tons, which is a unit unique to forestry. For those on the call unfamiliar with it, bone dry ton is a ton of wood that is completely, as the name implies, dry. Of course, wood can vary in moisture content, and so it's a nice standard that we all use. So yeah, this 3 megawatt facility will consume around 45,000 bone dry tons a year, all chipped in the forest.
Yeah, so that is, like I said, essentially you want chips delivered to your mill clean, essentially ready. There will probably be some amount of drying that does as it stockpiles, and you take it from there and just feed it into the machine. And what's that? What you showed us is pretty small, right? So what's the process for getting the material from a stockpile of chips into the machine?
Yeah, so we'll use, more interesting than that is even how you get it on the ground, in my opinion. So as these chip vans show up to a bioenergy facility, it's kind of the most simple option, but it's how it's done in the industry is the trucks will drive onto essentially a bed, and the entire truck just gets tilted up like you're emptying the ending of a bag of potato chips into your mouth, kind of. And that's how you get them out of the van. Then they're stored in piles, as mentioned. For our facility, the equipment and machinery that we're using is actually, to David's point, extremely compact, and most of the site is used for material storage. Once it is on site in those piles, we'll move it with mechanical machinery. So think of like a small bulldozer to get it into place, and then it goes onto a set of hoppers, kind of like conveyor belts. So it's almost essentially entering a factory-like setup at that point.
Gotcha. I got one more on that topic, and then we'll go to Lori's
Perfect.
question. So
We actually have 2 questions, Dave, from a couple of students.
okay. Have you considered the difference between hardwood and softwoods and the effect that has on energy generation, or you just get a mishmash of chips and it is what it is?
Yeah, that's an interesting challenge that we're trying to deal with on the engineering side. And part of the reason for torrefaction is that it can homogenize things a bit more. Because not only is there a question, of course, of what's out there in the woods, right? And there's a lot of science that you can go into on surveying, assessing, and trying to do this work. But beyond that, it's not even about what's out in the woods. It's about what's going to show up on your doorstep, right? And maybe statistically, certain species of woods are at lower altitudes that are more likely to get addressed by fire treatment. And so even though they don't make up, they may make up 30% of the forest, but they're going to be 80% of what shows up on your door. And those are all really hard challenges. So you actually have to build some of this flexibility into your system, which is, again, why we use this torrefaction and gasification technology. And so while we might get slight interruptions in service, the goal is that we can, at a high level, minimize overall downtime. Yeah, I think Lori has a question that looks definitely for the CAL FIRE folks as well.
Yeah, so Lori says, when cleaning up after a wildfire, how does machinery and processes involved in mitigation and reforestation impact wildlife? So Probably most immediate after a wildfire, there's sort of like the fire line cleanup that occurs. And a lot of that is from our suppression operations. And we mitigate the erosion off of that the best we can with the materials that are available, utilizing water bars and other if there's any vegetation, we can lay that across any denuded areas that were or dozers that operated or something like that. But then, post suppression and post repair of those suppression lines, when they go into salvage operations, if it's a commercial type space, there's they have to follow the timber harvest practices, which were some of those that I spoke about. Those rules govern, how they interact with the wildlife, any surveys that are necessary, and stream buffers and steep slopes and things like that. And if you looked at that scene from where Justin was presenting with the chipping operations, I don't imagine there's a lot of wildlife left there immediately after the fire, which is when a lot of operations occur, mostly because the value of the logs diminishes with time as it sort of stands and rots. And so a lot of the utilization, at least from a lumber store standpoint, a lot of that utilization occurs pretty quickly. Yeah, so that I don't know that you have anything, Dave, you want to?
No, those are valid points. And like I said, there's post fire, there's a certain amount of dead trees left standing for wildlife habitat. And at that point, post wildfire, our focus is the impact has been done. Our focus from CAL FIRE's point of view is, again, cleaning up the damage we caused, suppressing the fire. From, a timber management point of view, it's trying to salvage what value is left in some of those logs while complying with the forest practice rules. And we'll touch on what a water bar is too. So the forest practice rules are what govern everything we do in terms of commercial timber operations in the state of California. It's 300 or so pages, a very small font. So there's a lot of rules that goes into forestry, and a lot of that has to do with minimizing erosion and protecting wildlife. So depending on what you're doing, what species may be present, there are project design considerations that go into minimize impacts to that. And so moving on to what is a water bar, it's basically it's 6 inches deep, or it's an angled pile of dirt. I don't know how to word this. I was trying to find a picture, but basically it's so we're trying to break up the slope distance. So as water is draining across these surfaces, it's traveling less of a distance and it's draining off in preferred location into less erodible material.
Kind of like a speed bump, don't you think?
Yeah, that's a good one. An angled speed bump on like a dirt road or a dirt trail. I'll see if I can find a picture and throw it in the chat too.
Yeah, I like to consider it basically takes surface flows and changes its trajectory. So instead of going down the hill with the gravity, it gets collected and then slowed down and then shot off to the side, basically taking the force, the water's force away, so that it does less erosion.
Yeah, my lesson has been on a mountain bike, you don't want to go too fast downhill and hit a water bar, because then you would get airborne and holy cow, you can crash.
Absolutely. Vehicles as well. Okay, we're at 5:15, our anticipated ending time, and it looks like there's no questions. So again, appreciate everybody that presented and attended and participated and asked questions. This is going to be posted on the Envirothon webpage. And from the discussion with Jovita, there will be an opportunity for people watching the recorded presentation to submit additional questions as they get the opportunity to do so. So if any other questions come up as you rewatch this or you discuss forestry and its relation to Envirothon, please feel free to reach out. I guess I didn't really think about how those questions will be submitted, but I'll let Jovita or Nancy touch on that one. So,
Well, the thing is, any questions, even from those who watch the recorded version of this webinar, you could send it to David, who could let Nancy and I know, because I hope David will coordinate with Jason, with Jason, Farah, and Sutton on those questions for a response. And I want to say to the students and teacher that you may see a forest test question based on the information that was presented here at this webinar. But I want to join David and Nancy to thank Jason, Farah, and Sutton for helping us and supporting California Envirothon.
Thank you guys.
Thank
It's been
you.
really fun.
Take care.
thanks everyone. Thanks, Austin. That's a good reference.
Thank you. Bye.
All right.
Thanks, everybody.